Imagine trying to see molecules that are so small you would need a microscope 100 times more powerful than the ones you used in high school. Now imagine trying to manipulate those same molecules to build something from the molecular level. In doing so, you can adjust the desired item's weight, properties, or even create new technology altogether. This is the exciting world of nanoscience and nanotechnology. Nanotechnology was first discussed on December 2, 1959 by theoretical physicist Richard Feynman in a talk entitled "There's Plenty of Room at the Bottom." The term nanotechnology, however, was not coined until 1974 when Norio Taniguchi, a professor from the Tokyo University of Science, coined the term himself. In 1981, when new microscopes allow the ability for scientists to see a molecular level, is when nanotechnology became a true field of study. Now, how small does nanoscience and nanotechnology operate at? 1 nanometer is a billionth of a meter. There are 25 million nanometers in an inch, and a sheet of paper is about 100,000 nanometers thick. In comparison, if a large marble was about 1 nanometer size, the Earth would be 1 meter in length. Nanotechnology involves the ability to separate, deform, and consolidate atoms at this nano level. What is an atom, you may ask? An atom makes up everything in existence, from you and me, to the food we eat, to the cars we drive. Everything on this Earth is made of atoms. Atoms are also impossible to see with the naked eye. With the ability to create something from a molecular level and adjusting these atoms, scientists can create new lightweight material, make energy creation more efficient and cost-effective, as well as create new medicines and pharmaceuticals. Well, how do we alter molecules? And where do we start? Start with the nanoscale, which is the length scale used to determine the scale of nanomaterial, which is material at the level of this very, very tiny microscopic level. It's determined from 1 to 100 nanometers. Nanomaterials come in different shapes and are identified by their shape: particles, tubes, wires, cones, etc. And in order to see these materials, we need to use a high-power microscope called the Scanning Tunneling Microscope, STM for short, which was discovered in 1981 by Jared Beining and Heinrich Roher. It allows us to see at the nanoscale and also to adjust and move those nanomaterials to create new properties for the elements that we're looking at. They won the Nobel Peace Prize in Physics for this achievement in 1986. The first example of anyone doing anything on the nanoscale was in 1989 when IBM spelled out their company letters in xenon atoms on the back of carbon atoms. Imagine you are holding gold and you put that under an STM microscope. And now we are looking at the molecular nanoscale of this gold. Now, the nanoscale was the extremely small length scale that we use to identify nanomaterial, and nanomaterial are the things that make up atoms and etc. We're basically looking at, underneath this high-power microscope, a long wire that you would see at the back of your TV, and inside that coating the red, yellow, and blue wires that make up the entire cord itself. These wires determine what gold is, what color it is, everything about gold. Everything about gold is determined by these wires. And by adjusting these wires, we can change the strength, conductivity. We can also learn to identify where these molecules exist. Example, if we were able to determine where gold exists in ourselves, we can determine where tumors are, because gold particles are also involved in our tumors. We can surgically extract those tumors without affecting the positive cells that are around them and damage less of our body when going under surgery. Currently, there are 1,600 nanotechnology products available to the public. Products that are available to us include the Samsung 9 nanometer flash memory device, which holds more memory than others, the YEN effect, which is a cosmetic cream that uses gold and organics to target the cell's natural hyaluronic acid increasing growth, and the Optisol sunscreen, which offers increased protection without the need for higher SPF and also has an anti-aging property as well. Baby blankets that use silver within the textiles to make the blanket stronger, as well as additional protection for the baby, are also on the market. Nanotechnology is also affecting potential energy efficiency and cost effectiveness. Brian Porgal, a chemical engineering professor, has recently discussed the potential implications of nanotechnology. By using a synthetic ink on solar panel crystals, inside the ink would be better able to absorb solar rays and expand solar production. Aluminum nanotubes, which can conduct electricity and are some of the strongest material available in nanoscience, could be used as a conductor or semiconductor and are already used in automobile and aerospace technological pursuits. Nanotechnology was originally called science fiction when Richard Feynman presented his talking points back in 1959. Today, nanotechnology is growing the way for future industries and technologies to change the world and progress humanity. The implications this technology can have when it becomes more streamlined will be limitless, from its medicinal purposes to making energy more cheap and efficient, in its effectiveness in the automotive industry, or making material lighter and stronger and even cheaper. Nanotechnology, safe to say, is in fact the future. Thank you very much.